2b. And 2b is it's a process that we've definitely seen in year 11, and it's a fast way of doing differentiation. I've seen even some of you guys doing it to check your answers to first principles, so that's absolutely fantastic. And so the way we arrive at it, right, is we've got the summary table there again, is we basically start to notice this pattern, right? So if we've got x squared, we see that the derivative is 2x to the 1. If we've got x to the 3, we see that the derivative is 3x squared, x to the 4, 4x to the power of 3. And so last year when we were unpacking it, we started saying, what do we anticipate the derivative would be if we had x to the power of n? And so we're trying to identify some relationship between these. If this is our function, this is our derivative. And so that's where we sort of start talking about that word conjecture and what conjecture means. What do we conjecture the answer to be here? And the power rule we derive nx to the n take 1. Okay, so that's the one that we've seen, and that's the one that we're going to use today. We will get straight into it. I'll just point out to you guys the process that I've written down there. So before you differentiate, this is what you absolutely have to do. Ensure all x terms are at the top in the form x to the power of n. The function must be fully expanded, and it must be at the top of the fraction. We always differentiate in one single step, and then we'll simplify if required, and I'll talk about simplification as it pops up. Let's get straight into it. Our first example is y equals x to the power of 7. Okay? So if we're going to apply simple differentiation here, we have to have it expressed at the top of the fraction as a single power. This one's just ready to go. dy on dx will be 7x to the power of 6. So just one thing to point out here, you need to be really clear. This is y, this is dy on dx, okay? This is the function, this is the derivative function. This tells you the y value, this tells you the slope. Okay, on to the next one. We have y equals 4, take 3x to the power of 4 plus 6x. Okay, so we're going to go through and differentiate. And I'm just going to differentiate each term. We're going to differentiate all in one step. We can see everything's at the top of the fraction. There's no denominators there. Everything's expressed as x to the power of n, except the constant term here. So we're good to go. Let's differentiate, and we just go term by term. The derivative of a number is always 0. Whenever you have a constant, that part's going to go to 0. All right. Now this minus 3, let's just leave that for now. That's just going to hang out there. And we're looking at x to the power of 4. X to the power of 4. So when I use the differentiation rule, it becomes 4x to the power of 3. All right. So x to the 4, 4x to the power of 3, that's the power rule. And that minus 3 is just hanging out the front. We've got minus 3 lots of it. And then we have plus 6x. Now the derivative of kx will always be k, therefore the derivative of 6x is 6. Okay? So that's the derivative there. It can be simplified a little bit, can't it? We don't need to write 0. Minus 3 times 4 is 12. And then we have this plus 6. Now, in the textbook, they will simplify it. Okay, and it's good algebraic skills for you to practice the simplification. In a test and exam, you are not required to simplify. If you look at the test for chapter 2 there, our first test, it says differentiate the following without simplifying. All of the previous 8 tests. The only time you're required to simplify something is when it gives you a function and it says show that the derivative is this. Okay, if it says show that the derivative is this, then you need to manipulate it in order to get to that answer. Good, Stella.
What happens to the minus at the front?
Yeah, thank you. That should be good. Yeah. No, quiz me up. I'll miss those little things. All right, on to C. So with C, we've got a problem already. We have 4x squared plus 7x multiplied by x take 2. So if we just check the process, the conditions that we need, it says ensure it's all at the top, the function is fully expanded. Here we have one bracket multiplied by another. That won't do. We have to expand it, and then we can differentiate it. So in order to expand this then, we're just going to use FOIL. All right? So I'll do this slowly. We have 4x squared times x. So the first terms, that will be 4x to the power of 3. We have the outside terms. We have 4x squared times minus 2 will be minus 8x squared. We have the inside terms, 7x times x will be plus 7x squared. And then we have the last terms, 7x times minus 2. Okay, now we could differentiate here, but we've got some like terms we can collect. Like terms have the same powers, right? Here I've got minus 8 plus 7, so they can collect because they have the same power of x. So if I have minus 8 plus 7, that's just going to leave me with minus 1 log x squared. Okay, so we're very clear, all right? We're very clear. This is what y is. We've got it to a stage where we are now ready to differentiate. Okay, so sometimes we need to manipulate it first. We're ready to differentiate. Here we go. dy on dx will be. Now, you can leave the number out the front like I've been doing, or if you know that that's going to be 4 times 3x squared, you can go straight to the 12x squared. That's absolutely fine. Okay? So this term goes to 12x squared, this term goes to 2x, and this term goes to 14. Now, one big mistake that I do see people do is they just go equals, 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 equals. They're not equal. These three are equal, but in this step, we've performed something, so we need to communicate that. Absolutely have to. dy on dx. We've moved from y to dy on dx. Okay, so you must make sure you notate that. Very good. On to, let's stop there before we get on to D and E, and we might, I think, let's just get straight into the exercise, and we can come back and have a go at D and E after recess. All right, so I've said you need to make sure everything is at the top of the fraction as a single power of x. And so we've got this fraction, and so we need to solve that problem. We need to get rid of this x somehow. And so what we should do is what's called splitting the denominator. What we're going to do is we're going to rewrite this as x squared on top of x, take 4x on top of x. Let me show you why that's a legitimate operation. Like if you think of 3 take 1 on top of 4, okay? That would be 2 on 4, right? 3 take 1, we could write this as 3 on 4 take 1 on 4. And 3/4 take away 1/4 is still 2/4, right? So that means one thing we can do is when there's a denominator, we can split it. The denominator applies to both terms in the numerator. And then all we're doing is using index laws to simplify it. So here we have x to the power of 2, and at the bottom we have x to the power of 1. So in the next step, we'll have the top power take the bottom power, 2 take 1, that'll just be x. And then here we've got x at the top, x at the bottom. It's just going to simplify to x take 4. Okay, we've expressed it at the top of the fraction as a single power of x. We're ready to differentiate. The derivative of kx is k, the derivative of 1x is 1, and the minus 4 disappears. So that's our answer for D. Now, in E, we're going to express, whenever we have roots, we want to express them as x to the power of n, right? So we've got f of x, we've still got the function here. The first part is going to be 2x to the half, and then the second part is going to be 5 on top of x to the power of 3 on 2. Anytime you see x root x, I'll just break that part down. X root x, that's x to the 1 times x to the half. They have the same base, so you add the powers together, 1 plus a half, and that's 3 on 2. 1 and a half, 3 divided by 2. Okay, so if you want more detail on that, but all you need to know is x root x is the same as x to the power of 3 on 2. This is as a root, this is as a power. Okay, so that's good. We've expressed everything as x to the n. In the next step though, we need to make sure everything's at the top of the fraction. And this term is not at the top of the fraction. We need to take that x to the top. And we do that just by making the power negative. Okay, so that's our index rule, where if we have 1 on a to the n, we can write it as a to the minus n. The 5 is just hanging out, it's just 5 times it. 5 times that. So this is f of x, right? This is f of x, this is f of x. We're ready to differentiate. And so if we're told f of x, we use the notation f dash of x. If we're told y, we use the notation dy or dx. Okay, so you just use whatever notation they give you. And I'll just do this one nice and slowly. That 2 is just going to hang out the front, and we have x to the half. So using the power rule, x to the half becomes half x to the minus half. Alright, so that's the first term. And then the second term, that 5 is just going to hang out. And we're going to have minus 3 on 2, x to the power of minus 3 on 2, take away 1. That will be minus 5 on 2. Okay, so you get full marks there, right? You have differentiated it. Nonetheless, with these root ones, the textbook does like to simplify them. So I'll just explain that a bit. So firstly, we have 2 times a half, that will cancel. And we have x to the minus half. So that's the same as 1 on top of x to the half. And x to the half is square root of x. So the first term they'll have is 1 on square root of x. That will simplify to 1 on square root of x. Okay, with the second term, it's a little bit more complex. We have 5 times minus 3 on 2. So the number out the front is going to be minus 15 on 2. And then x to the power of minus 5 on 2, we'll use the index law to take it to the bottom. X to the 5 on 2. And x to the 5 on 2 is the same as x squared root x. Alright, so we saw x to the 3 on 2 is x root x. X to the 5 on 2, or x squared root x, is x to the 5 on 2, using the same rules. If I can just remind you, you get full marks here. Okay, so as long as you're following along to there, I'm happy with that, but do practice this simplification. It will help. All right, we'll stop there. Enjoy your recess. If you've got a question, hang around. I'm happy to address